All right, hello once again, Jeff Scott from Jeff Teaches Programming. In the last video, as you can see right here, um, I started to go through an introduction to TypeScript, and the way I'm going to do this, I talked about TypeScript in that particular lecture, but what I'm going to do is I'm going to take this article that's out here from freecodecamp.org called Learn TypeScript in 1 Hour, and it's a good article, and it's well done, goes through virtually everything that you need to know about TypeScript. But what I didn't like about it is, again, there's a
In
video
this
that's
course,
set
you will
up,
master the essentials of TypeScript.
and in here, what we have is this. I said before, I don't know if this is an avatar or what, explaining everything to you. So I decided that rather than doing it like that, what I would do would be to try to glean what this person has done and try to explain it to you by putting the actual code examples into the TypeScript playground. All right, plus giving an explanation of what this person gave in the document as well. And after I get done with that, I'm going to write a fairly simplistic JavaScript calculator, and then I'm going to turn that JavaScript calculator into a TypeScript calculator. And then after we do that, finally, after we do that, we're going to go in and rewrite the BMI program that we did in JavaScript as a TypeScript program, and do the same thing with the payroll program. Remember, this here lets you put in TypeScript, click the run button, and it shows you the equivalent of JavaScript, or what would run in the JavaScript. It goes through transpilation, I believe it's called. All right. Hold on one second. Let me get back to my right page in my notes here. Just give me. All right. So the first section that's in here, as it says, is an introduction. Now this person calls TypeScript JavaScript with syntax for types. I'd agree with that. As it says, it's all about type safety. You can choose not to use type safety in TypeScript, but I'd recommend that you do it. And they talk about some of the things that can go wrong with JavaScript. You can do this. In JavaScript, you can put in this. Get rid of this and this. If you type in 2, the number 2, plus the string 2, what JavaScript will automatically do is it will concatenate those two together into the string 22. You cannot do that with TypeScript. In fact, if I come in here and try to do this, so let's get rid of that and let's put in this. All right. Now, when we do this, let's say let sum equal 2 plus 2. All right. And we've got here console.log that. Let's do a console.log sum. And run it. All right. Well, what it's showing is the same thing because it has basically taken this. All right. It has taken this and it's put it down into its JavaScript equivalent. You don't want to do that. This can lead to really weird things. Why would you want to do that? All right. And I'm not really sure to give you an answer. So as it says, TypeScript is a programming language built on top of JavaScript. It's also known as being a superset of JavaScript. It offers things, as it says, that aid in more robust and maintainable applications. Now, it says while reducing development time, it actually is going to increase development time as you're learning it. All right. But what TypeScript does as opposed to JavaScript is if you write TypeScript in the quote right way, unquote, and you use this static typing, it makes you a better programmer. It makes you program the way that at least I was taught programmers should program. All right. And they mention there that there's two basic types of programming languages. You've got static typing. With static typing, what happens with a statically typed language, all right, is that it looks at your program at compile time, and if it sees things that it doesn't like, it checks it for you and it lets you know, hey, there's an issue. It doesn't wait till runtime. That's what you get with TypeScript. On the other hand, with dynamically typed languages like JavaScript, basically it goes and at runtime it figures out the type checking. All right. Now this setup thing that they come in next, I'm not going to go through all this. All right, I talked a little bit about this last time. If you want to install Git, and I'll save this document out there as well. All right, let's save it right now out to my desktop, front end, TypeScript, and I'll call it Free Code Camp Summary. All right, so there it is. All right, hopefully I won't get in trouble from the people from Free Code Camp. I definitely would recommend that you watch this. The person who did this really does know what they're talking about. I'm just trying to simplify it so you don't have to sit and maybe it's going to take more than an hour. I don't know if I'm making it better or worse. All right, if you haven't installed Git, you should. Here's the URL. If you haven't installed Visual Studio Code, you should. Here's the URL. You will need node.js in order to work with this. Here is the URL for installing that. And you want the LTS or long-term support version. All right, I did this at the end last time. But again, to verify this, and I'm not going to go through all this, I'm not going to create the application. But I did do this. I went in and did the install. And then I came in and did node -v. And it said I'm running the latest long-term support version of Node, which is 24.16.0. And then I installed TypeScript by using that command that's shown there, npm install -g TypeScript. And to verify that that was there, I typed in that, and it showed me that I'm using that. All right. Now, we will go through from here all these steps when we do go in and create our, when we do come in and we create our JavaScript calculator and we convert it into TypeScript. So I'm going to put off all that stuff, and that is lines 58 through 119, so about 60 or so lines until we get to that point. All right, talking about types. JavaScript has certain built-in types like number, all right, string, Boolean, null, undefined, and objects. TypeScript has some that are not used in JavaScript: any, unknown, never, enum, and tuple. With type annotations, which I believe you should always use, you explicitly specify the type of variables. Now, back when I was teaching full-time, I would harp on the difference between explicit and implicit. Explicit means you're doing it. Implicit typically means you're allowing the software to do it. So by you explicitly specifying the type of the variable, as it says there, you help TypeScript, the compiler, understand and enforce this type checking. You put a colon at the end of the variable name and then a space, and then you followed by the desired type. So here's a couple of examples. So if we put this in, what's shown right here, again, I'm just going to jump back and forth in here. And I'm going to get rid of all this. All right, and I'm going to do this. And now if I click run, notice what I get. I don't know why I'm still getting that hello world, but that's okay. I think it's just adding on to this. My number is 42. My string is hello TypeScript. Totally fine. Now, sometimes you don't know in advance what a variable will hold, so you can also do it like this. There could be some code in here. So this is another way of doing it. In other words, you declare the variable and its type first, but you don't initialize it to a value till somewhere later in the program. And if we run that, what you see is the exact same thing between here and here. All right. It may be advantageous to do it one way as opposed to the other. I was always taught if you know a variable's value at the beginning, you should just set it right away. As it says here, and I agree with this, using type annotations ensures that your code is more robust, maintainable, and less error prone. Also, if you're going to have a big project that you're going to work on with others, it makes it easier to do things the right way. If you don't do that, if you do this, it's known as dynamic type determination. What that means is you're not going to use type annotation. You're going to let the language implicitly infer the type. All right, so let's do this. I'm going to change this in just a second. So I'm going to get rid of that. I'm going to paste this in. And we'll say, hello world, using, what do they call this again? Dynamic type determination. Dynamic type determination. And you'll notice if I run this, it works just fine. But it's funny because I've read a bunch of articles on TypeScript, and some actually recommend you do it this way. I don't understand why. I don't see again what that would buy you. All right. So as it says here, TypeScript will automatically infer the type of the variable as a string. However, as it says, while TypeScript can infer types, it's generally not recommended. It can lead to unintended issues and reduce code clarity. I agree with that. All right. If you want to let a variable hold more than one type, if you want to have it hold any type of variable, all right, you can set it to type any. Let's do this, but we're going to do this a little bit differently. So again, we'll get rid of what's in here. And what I'm going to do is I've got this. So what I'm going to do is I'm going to come in here and say console dot, what's going on here? Console.log, and we'll put in my variable. All right. That should be a little c. And notice that when we put it in and we run this, it runs just fine. 42, and then hello JavaScript. And the magic is by using that word any. Now, I say magic kind of tongue-in-cheekish because, as it says below there, it's not recommended that you do this. If you're doing this, why are you using TypeScript? That's be the question I'd ask. It can result, as it says here, in a few things. A loss of type safety, reduced code reliability, maintenance changes, and it can potentially lead to bad things. All right, I'm at 15 minutes, so I think I'm going to keep going and at least try to get through objects here. Yeah, we'll stop at functions. All right. Type annotations with objects in TypeScript, as it says, let you specify the types of properties an object should have. So look at this. We're setting up right here, we're setting up a person. And each person will have a name, which is a string, an age, which is a number, a job title, which is a string, and notice an address, which has got embedded in it another object, a string for the street, and a city, string for the city. And then we go and we set up somebody named Alice. So Alice is the name, 30 is the age, engineer is the job title, and Alice lives at 123 Main Street in Wonderland. If you don't want to do it like that, you can do it like this. It looks very similar, and it is very similar. All right, let's do this. I'll put in here Jeff. All right, so let's put in all of these like this. Just so you can see that it works both ways, that's all. So there's the first way. All right. And actually, let's see. I think we'd be able to now say console.log person ex1 dot, and notice it already has all the stuff for us. So we can say name, for example. And if we run it, we get Alice. All right. And if we do this again, but we put in the other way, and we'll leave that one in there. All right. And let's do a console.log again. And we've got what? Name, age, city, we'll do city again here, and I'll change this other one to street. And if we run this, all right, oh, I didn't do name. Oh, it's still EX1. That should be 2, sorry. Well, you saw that it worked anyway. All right. And there it is, Jeff. Okay, so everything worked. All right, jumping back in here then, let's take a quick look. Actually, I think this is a good place to stop because there's a lot of stuff in here, as you can see, with functions. So we made a good start here. All right, I skipped part of this, but we went through number 4 on objects, and we'll pick it up on number 5 with functions on the next video. I'll see you then.